All right, so we talked the other day about solving radical equations, and we're just going to do a few more examples of those. But remember, our steps to doing that included isolating that radical first, then bringing both sides to the power of whatever root it is, and then solving the equation from that. So to get rid of those radical signs, you've got to take it to those powers, remember. Okay, so here's an easy one that we are going to work first. So this is square root of 3x plus 1 is equal to the square root of x plus 15. Well, notice they're both square roots, so we can square both sides of that equation, and that gets rid of all those radical signs. So 3x plus 1 is equal to x plus 15. So now we just have a simple equation. We'll get all of our x's together. Then get all of our whole numbers on the other side. So 2x is equal to 14. Divide both sides by 2. So x is 7. Now, you always need to check your answers on these, because there are several that will have extraneous solutions, because when you're dealing with these square roots, sometimes the negatives or even sometimes the positives are not good answers. They do not make the equation true, and so we have to throw those out. Okay, so we're going to check the square root of 3 times x, which is 7, plus 1. Is that equal to the square root of 7 plus 15? Well, 3 times 7 is 21, plus 1 is 22. So the square root of 22, is that equal to the square root of 7 plus 15? Well, 7 plus 15 is also 22, so that works. So our solution is just 7. Okay, so here's another one. Remember, we want to isolate sort of these radicals. And, you know, I would not want to cube that whole side of this. So we want to take one of these and move them over to the other side. So that's the cube root of 9x is equal to the cube root of x minus 24. So now we're ready to take both sides to the third power. We're going to cube both sides because it is a cube root. Well, when we do that, we're going to get rid of both of those radical signs, leaving us with the simple equation 9x is equal to x minus 24. Let's get this x on the other side by subtracting him. So we get 8x is equal to negative 24. Divide both sides by 8. So x is equal to negative 3. So let's check and make sure negative 3 is a solution. So the cube root of 9 times negative 3 minus the cube root of negative 3 minus 24, is that going to be equal to 0? Well, 9 times negative 3 is 27, so we've got the cube root of 27 minus the cube root of negative 3 minus 24 is negative 27. Is that equal to 0? Well, the cube root of 27 is 3 minus the cube root of negative 27 is a negative 3. Does that make 0? Well, no, it doesn't. 3 plus 3 is not 0. So 3 is not a solution, so that is no solution for this one because we only had the one answer. All right, let's look at another one. So what here, we were going to, let's see, isolate the radical. So we're going to subtract 5 from both sides. So we've got the square root of x plus 7 is equal to x minus 5. Well, remember, we have to now square both sides of that, and when you square x minus 5, that doesn't mean you square each of those terms in there. That means you have to write that thing out twice. X minus 5 times x minus 5. Please get in the habit of doing that. That's a very common mistake that people would make. That's going to be x squared minus 10x plus 25. Remember, when we have an x squared or quadratic equation, then those equations have to equal 0 in order to factor them. So we're going to move everything over to one side with its like terms. So it's going to give us 0 on this side, x squared minus 11x plus 18. So now we'll factor that. That should be x minus 9 times x minus 2. Negative 9 times negative 2 is positive 18, and that adds up to be a negative 11. So remember, we set both of those factors equal to 0 and solve. So that means x is equal to 9 and x is equal to 2. Now, especially when you have two answers, you always want to check them both and make sure. A lot of times only one of them will work. So first we're going to check x is equal to 9. So we've got 5 plus the square root of 9 plus 7. Is that equal to our x, which is 9? So 5 plus the square root of 16, is that equal to 9? So 5 plus 4 is equal to 9. So yes, that's a true statement. So 9 is a solution. Now let's go check x is equal to 2. So here we've got 5 plus the square root of 2 plus 7. Is that equal to our x, which is 2? So 5 plus the square root of 9, is that equal to 2? 5 plus 3 is not equal to 2. So 2 is not an answer, only 9 is. All right, we have one more example. Hopefully you're getting the hang of these. They're just a lot of fun to do, I know. So we're going to add x to both sides. So we've got 3 square root of x plus 1 is equal to x plus 1. Now normally I would want to go ahead and get rid of that 3 that's on the outside of that radical, but in this case I do not want to have to FOIL that x plus 1 if I divide it by 3. So I'm going to square this whole side here, and I'm going to square the other side. So remember, when you square the number on the outside of the radical, he is actually going to get squared. So 3 squared is 9, but then it's going to be times just x plus 1, because the square root of x plus 1 is x plus 1. Then remember, x plus 1 squared on the other side is x plus 1 times the binomial x plus 1, which gives us x squared plus 2x plus 1. So let's distribute this 9. Let's move everything to the other side of the equation. And I just sort of have the habit of always moving things to wherever that quadratic, the x squared, is always going to be positive, because that's just the easiest way to work with and factor something, is if that x squared is positive. So I always just move them to that side, if you wonder why I sometimes move to one side and sometimes move to the other. I look and see which way is going to be the easiest. Okay, so I factored that. So x squared minus 7x minus 8 factors into x minus 8, x plus 1. Set both of our factors equal to 0. So add. So x is equal to 8. X is equal to negative 1. So let's go check both of these answers and see if they are both true answers. So if x is equal to 8, we've got 3 square root of 8 plus 1 minus 8 is equal to 1. And notice I'm just putting that x in, 8 in for the x from my original equation up here. So we've got 3 times the square root of 9 minus 8 is equal to 1. Well, the square root of 9 is 3, and 3 times 3 is 9, or let me write that. So 9 minus 8 is equal to 1, and that would be a true statement. So we know 8 is a solution. Now we're going to check x being negative 1. So 3 times the square root of negative 1 plus 1 minus x, which is negative 1, is that equal to 1? Well, negative 1 plus 1, so the square root, that makes the 3 times the square root of 0, minus negative 1 means plus 1, is that equal to 1? Well, the square root of 0 is going to be 0, so anything times 0 is 0, so is 1 equal to 1? Yes, it is, so negative 1 is also an answer on that one. So always be sure to check those answers, because a lot of times you will have extraneous solutions that you want to make sure you do not put down as one of your solutions for that.